All right, so Nvidia just dropped some big news at CES around AI, and they're trying to make it seem like it's a really big thing. Now, is this going to be a big thing? Will this be a huge deal? So I'm going to give you my thoughts on the things that Jensen Huang and his crew gave us. I don't know if this is going to be a huge impact for the AI world, and I think it's solidifying my thoughts on AI, but let's dive into this today. All right, welcome to Startup Hack. I'm Spencer Thomason. Here at Startup Hack, we train software developers in our licensed coding boot camps and build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming tech teams and products. All right, so the very first thing that we're going to dive into is he revealed the Grace-Blackwell AI Workstation revolution. So Nvidia unveils the Grace-Blackwell Workstation, and they're touting this as a game changer for AI development. And I do think this is pretty impressive. It's packed with a punch of a supercomputer into a sleek, small form factor, not all that different from like a Mac Mini. So it empowers every developer and data scientist to run unparalleled with AI horsepower. So you can actually run some pretty large models with these. And let's jump into some of these articles and take a look at some of these because we've got some interesting information on these here. So let me get my monitor switched over here. All right, so Nvidia, as the headline says, Nvidia puts Grace-Blackwell on every desktop AI fingertips, right? So they announced that this is a new project, right? Project Digits features the new Nvidia GB10 Grace-Blackwell superchip. And so this can offer a petaflop of AI supercomputing power. So this is a ton, and we'll break this down here. So the GB10 superchip is a system on chip, so SoC, based on Nvidia's Grace-Blackwell architecture and delivers up to 1 petaflop of AI performance at FP4 precision. So this is really, like, to break this down, it has the latest generation CUDA cores with 5th generation tensor cores. And it can link with chip to chip, so you can actually link more than one of these things together to be able to run some of the largest models. So the really big breakdown here is that this has 128 gigabytes of unified coherent memory and up to 4 terabytes of NVMe storage, right? So what this does is it allows you to be able to run, let me jump over to this other article here because I think they break it down a little bit better for us. Oh, this is the one here I was looking for, right? So they break down a little bit more of the specs for us here. The device costs about $3,000, right? You can see it's tiny. It looks just like a Mac Mini, right? And so you can see that this is going to be really small. Comes with 128 gigabytes of power. And so let's look at the breakdown of the specs here. This is the one that I wanted to kind of dive into a little bit for you guys here. So there's not a lot to this guy, and this little tiny chip is what's going to be really powering this, right? So you've got the ConnectX, which allows you to do the GPU direct, right? You've got up to 4 terabytes of SSD storage on an NVMe. But the big thing to talk about here is the GB10 super chip. This is a Blackwell GPU with just a ton of computation power, 20 ARM cores into the CPU, and 128 gigs of low-power DDR5 memory. And so what this allows you to do is to be able to run these models on that and to be able to process against that really efficiently, right? Because this will be a SoC, so it's going to mirror closer to what you're going to see from some of the high-powered like H100 graphics cards. So this will be a really big deal for developers because you're going to be able to run a lot of these local models yourself, right? And so this will allow you to be able to run up to 200 gigabytes is what they're saying of models, right? Under 200 bytes. So even as the article is saying here, a good laptop will normally have 16 or 32 gigs of RAM, right? But this will be able to run with 2 of them. So if you link 2 of these, it'll run up to 400 billion parameters. So Meta's largest model, right? Now, they're not saying that they want you to run these as your production system, but it sounds like this is enough to be able to run a decent sized model for some applications, especially if you're just running for in-house. If you're running some really big and you're trying to run some of the largest 405 billion models, you will need 2 of these to be linked because they can be linked together. And then you could run the 405 billion input parameter on this model. So this is a pretty cool announcement. I'm pretty excited because I think it's nice to see not everything pushing toward the cloud. I mean, eventually they are saying that you would push a production system up to the cloud, but I think this will be interesting. So it's going to come out in May, so it's not here yet, as always, right? And they're announcing it ahead of time, and it'll be starting at 3,000. Now, similar, one of the things that this article links to here is Nvidia offers a range of similar devices with their Jetson Orion Orion Nano supercomputer, and I ordered one of these to be able to run 8 billion parameters on something about the size of a Raspberry Pi. And I ordered these the day they released these, and I still haven't gotten mine yet. Because as soon as I do, I'm going to do a review for you guys here and show you how I'm using it locally. But this one here, so the NVIDIA is trying to offer models for developers to be able to build against these, because, and I think this is really wise, and I'll get into a little bit more of why I think this is super wise, but I think this is really important for them to be able to understand that if developers develop against these, we'll see a lot bigger use of AI models. And I'm going to talk about where I think that's going to send us. So again, just to kind of reiterate these, so under the hood, they've got a double barrel boost for AI, right? Because it's the Grace-Blackwell combination of NVIDIA's Grace CPU and the Blackwell GPU to make a really big AI powerhouse. Now, the Grace CPU is an ARM-based marvel delivering 2-time performance jump for big AI models, right? The Blackwell GPU has a compute lithium tailor-made for the most demanding AI training and interface workloads, right? The NVLink allows you to connect the CPU and GPU for up to insane bandwidth, so up to 900 gigabits per second, which is huge. That's 300 times PCIe, right? So that's a lot. Now, the Grace-Blackwell at the heart of this is the new DGX Digit system, and allows you to just really spin this up and be able to start running AI stuff right out of the box. Now, they've announced some other things, and I'm going to dive into some of these, but I think this is really important as AI is starting, or as NVIDIA is starting to really focus on providing the developer tools to be able to run AI locally. This is going to be really important as we start to see where AI is going to fit, because right now the big race has been towards AGI. Obviously, you're not going to run AGI on a machine like this. Yeah, could you set up like 100 of these? I guess, but that'd be terribly expensive. So you're not going to run these to go toward AGI. This tells me that NVIDIA really actually does know where the market of AI is going to go, and that's where you're building AI for certain verticals. You're saying, hey, I'm going to use AI to accomplish this thing, not boil the whole ocean. And it feels to me like they understand this, because that's why they're starting to provide these developer tools in a size that developers can start to use. Because before now, you used to have to get your hands on an H100 used to cost you about $40,000. So that really priced out really any small startups. Now, $3,000 is something that most startups could start to find some money for, to be able to start to build on. And you can even use that if you wanted to build an internal application for doing some powerhouse AI stuff locally, right? Again, you're not going to run a massive amount of a cluster on that, but you'll be able to run some pretty good stuff. So that's kind of some of the first things that they mentioned. The next thing they announced was diving into their new lines of graphics cards. And these are the GeForce RTX 50 series, right? Now, these are going to be good for gamers, right? And gamers are super excited about these, but it's not going to be just for gamers. This will also be for some AI stuff too. So I'm going to kind of talk about this dual for gamers as well as for AI. Because these GeForce RTX 50s are really big powerhouses, but at the same time, while they also have insane performance gains with 4 times ray tracing boosts and 2 times raster improvements, they're definitely seeing some 5th gen tensor cores and some other things that are definitely going to play in to even how AI works on these cards, right? And it's interesting to see NVIDIA go into this again, because I think this is allowing some great cards to get into the hands of developers to make running some of these verticals and building some of these verticals a lot simpler. So let's dive into some of those specs. So I found this great thread, this mega thread of who was going through the GeForce announcement for 2025. And again, this is geared a little bit more towards the gamers, but I'm going to pick out a couple of interesting details here. So obviously the flagship device here, the GeForce RTX 5090 is crazy, right? 21,000 cores, right? That's just ridiculously high. 5th generation, for the tensor cores. 4th generation for ray tracing, and again, this is the same pretty much across all of these, except of course, number of cores, right? Now, the big piece here, though, is that this one is going to come with 32 gigs of standard memory. Now, the thing about GPU memory here is you want to remember that you can, when you're looking at how much inputs, how many billions of inputs your models can handle, it's going to be 1.2 times the size of the inputs, like for the gigabytes. So if you're looking at, a 24 billion input, you do 1.2 times that, and if the memory of that can handle it, then that's, what you can run against. So these are really, like, they've definitely increased the amount of memory that they are running on these, which is huge because it's interesting that this is actually just slightly slower than the 16 gig. And so if you're really looking for speed, it's this, because your VRAM speed is 30 gigs versus 28, but ultimately, this is still pretty fast, right? But your memory bandwidth here is just crazy high, right? So this is going to be able to run pretty much any of your, not quite your 48, but any of your 24 billion input models, right? So this is going to be a pretty powerful card that you can do a lot with, even from an AI perspective. So if you're a developer, you can look in the range that these are going to be $2,000, slap this into any decent modern desktop, and you got a pretty good development machine for running some pretty serious models. Now, you're obviously not going to be running things, and so that's where that $3,000 mark starts to get kind of interesting, right? Because if you look at the Grace-Blackwell design here that they're talking about here, these ones here are this is definitely the deal then at 300, because you can run a 200 billion parameter model. So this is definitely optimized. But if you want a dual, use card here, you can definitely use a desktop, and this will give you 32 gigs. So you can still run some decent AI models here. But bang for buck, this is where, these Grace-Blackwells are going to be really the big thing. But it's interesting to see in these announcements that, and if you are gaming, and of course, Nvidia still is, providing graphics card for a lot of gamers, these are really impressive specs, and they're definitely squeezing more and more out of these cards. So I think we're seeing some pretty interesting pieces even for those, right? And so lots to see there. And so this is a huge piece for the announcements with the graphics cards as well, just both for the AI development as well as for gaming. So some of the other things that Captain Huang run through as part of his CES keynotes is he talked about the Omniverse updates for groundbreaking virtual world and digital twin simulations, right? Nvidia Metropolitan platform upgrades for smarter, safer sites with Edge AI, right? So he talked about a lot of different pieces that we could run through here. But really, I think the interesting push to this is that there is definitely, Nvidia has a relentless push on hardware front to fuel the AI revolution, right? Definitely everything is still around AI. I know there's the thing about gaming, definitely aren't hearing anything about crypto, right? But you really want to see it to be able to democratize access to supercomputing for AI devs, right? And this is a big piece because they're taking a play out of like Microsoft's playbook, who for years have provided developer tools to be able to build the ecosystem, right? Microsoft has been key to say, hey, here's some free developer tools or inexpensive developer tools. And NVIDIA is trying to do more to get development pieces into developers' hands so that they can continue to build what the next front of AI is going to be. Now, at the same time, we can definitely tell that AI progress is slowing after a 2022 through 2024 breakneck pace, right? I know a lot of people are going to be like, oh, see, this is like, but the thing about this to remember is that I'm going back into some of these other ones, right? There's the Grok delay. There's some of these other things that we're definitely seeing a slowdown. And as we see these slowdowns come into place, you're seeing the AI, like they're pushing for AI here, but you didn't hear a whole lot about AGI today, right? And why is that? Is because they're working to understand that AI is going to be fitting into verticals. We're going to see it in healthcare. We're going to see it in legal. We're going to see it in some of these places where you're going to be able to see it hit, and you're going to have them build into verticals, right? But you were not going to see them talk about delivering AGI. He didn't say, hey, look, you can strap together 10 of these new developer desktops and we can build AGI. So what we didn't see from this announcement was some amazing delivery of a new server-side graphics card. You notice that everything is geared around development for AI. You didn't hear any update on the new H100s, right? Because the H100 is still the server, the go-to server card for running AI, right? So you're seeing that they're pushing more towards, hey, how are we going to build software towards AI? And that's them knowing that we're hitting this. And I'm going to give another video tomorrow all about where we're at in the AI curve. So make sure you like and subscribe to the channel because I'm going to be digging more into this tomorrow, right? So he's talking about providing for CES, right? He's talking about providing more tools for developers because we're seeing that they're not leaping forward. And so they're going to try to push back to the developers and let developers see what they can create with AI. Remember that RAG and some of these things are things that developers came up with to really surge forward on AI. Hardware alone is not going to grow us towards AGI, at least not in the short term. So tools like the Grace-Blackwell put unparalleled capabilities for developers' fingertips. And there's breakthroughs that are going to come as the human ingenuity turbocharges with the coupling of these great tools plus the LLMs that we have, right? And that's why we've got to continue to really push forward and embrace an AI adventure. So we need to take these tools as developers, use them to push forward. But in NVIDIA's announcement, what's lacking from it is new server cards, right? And this is going to be where we're going to see that you're not seeing a huge growth in a lot of these areas. Now, I know a lot of you are going to come back to and say, hey, but these new chips are going to end up in servers and some of that, and there will be definitely some comparisons, right? We're going to see some of this coupling of the CPU plus GPU to see acceleration of that. And I do think we'll see some more of that into servers, but I don't think you're going to see it in the leap forwards that we've been seeing development of AI over the last 2 years. So I think this really continues to hyper focus on the fact that we are going to see a slowdown in AI or more of a niche of AI development, right? It's not a race to AGI, to creating this super god that a lot of people think AI is going to become. It's not going to replace developers. They're empowering developers. If it was going to replace developers, why would NVIDIA be spending so much work to give tools to developers? So what are your thoughts? I'd love to have a great discussion. The best compliment you can give me is to leave a comment down below. So make sure you like and subscribe and leave me a comment. If nothing else, to say hi. Here at Startup Hack, we love to train developers in our licensed coding boot camps and to build custom software solutions for companies. So reach out because we'd love to help. And we've got an offer for you here, and we'll catch you guys next time.
Want to become a software developer but don't want to spend 4 years in college and rack up massive student loan debts? Think you need technical expertise to get started? Welcome to Startup Hack, a better way to start your software career without student loans and years without income. One-on-one tutoring is included so you never get stuck and have guidance through the whole process. No technical experience is necessary. Learn at your own pace and in your own space. Startup Hack has worked with local state agencies in your area to make it so that qualifying students can get the program costs covered entirely and students can start earning while they learn.
Hi, I'm Jacob, and I completed the full stack development course offered by Startup Hack. One thing setting Startup Hack apart from any other coding bootcamp was the quality of one-on-one tutoring available. All of the projects that we did were challenging and thought-provoking, but left me feeling very accomplished and very prepared for my first job that I was offered just days after completing the program.
Hello, I'm Tom, and I completed the full stack development course offered by Startup Hack, and I must say that it was an excellent experience. The tutors is what set this course apart from others. They were knowledgeable, experienced, and always available to help provide me with guidance and support. Do not hesitate to take advantage of this affordable and efficient software development course.
Complete our 3-month coding bootcamp, gain hands-on experience, and land a paid internship. With 2 years of experience on average, our graduates are making over $80,000 per year. The 3-month program includes technologies from Microsoft, Google, and Facebook. No debt, just a quick path to earning. Check out startuphack.com to code your future and start today.